Good morning. I'm on site here at Embedded World 2023, and joining me today is Eric Pan, founder and CEO, Seed Studio. We're going to be talking about perception systems. Could you start by giving us a brief introduction to yourself?
Yep. Good morning, guys. And Seed Studio has been in this business since 2008. We're doing a lot of open source hardware modules with Digi-Key, and now we are making more devices. So it has been quite a journey, and we are very happy to be back to Embedded World and have a chat with you.
Oh, excellent. Well, could you introduce the company for us?
Yeah, so we do a lot of things. So Digi-Key, we make like hundreds of thousands of open source modules. Everything you can imagine, from sensor, microcontrollers, and towards the display, etc. So we started with the open hardware movement and all the maker communities by making and building the stuff for them. And we also provide services for startups and the engineers to go all the way from ideas to prototype and to products. But for the last 5 years, we found that it's very difficult for engineers to build things from scratch. And so we have to avoid that, we build a device as a reference design. For example, we build the sensors for agriculture, and it's not an easy job. You have to make that thing survive in the wild for 4 seasons, from winter to summer, and it has to be very cost effective, and it has to be very low power consumptions, and it has to be open so people can build all kinds of things on top of that. So we do the engineering challenge ourselves, but we open that up so people can reinvent with these spaces.
Okay, great. Well, let's talk about the digital world and the importance of sensors. It's been described that the sensors are the feelers of the digital world, and just wanted to know, what role do you think they play in the digital world?
I think the sensor was the first module we made back in 2008, because there's so many people trying to start with Arduino. But some of the sensors are relatively more complex to make with. So what we do is we turn that into a module with the standardized interfaces. And that kept going for many years until today, for 15 years. Whenever we give people, especially land engineers, like software developers, biologists, like conservationists, give them a new sensor. They look at their own problem and find a new way to use that. So whenever it comes with AI, especially for the last few years, they can reinvent the sensor in a different way. Like with the right model, with some gas sensors, they can be a smart nose. The camera with a trained model, you can use it like for panda sensors, for bug sensors. So whenever a new sensor is invented, we find a new way of resolving problems that can becoming a new way for the IT infrastructures to get more data from the real world. So we keep the sense of that. And besides engineers, we see a lot of scientists. Whenever they use new sensors, they get more data. And that's a shared platform between the scientists and the system integrators. Like if, for example, you have a farm, you have all the chickens and you want to make them healthy, but you don't have the science behind that. The only thing you can do is keep monitoring and share that data back to the scientists. The scientists who has been starting the chicken growth or the brewers of the species, they know the best way to raise them, right condition for temperature, humidity, CO2, NH3, so they can remote diagnosis and to guide the farmers to grow more healthy chicken, use less medicines. So I think the sensor is actually, it's not only the feeler, the neural end of the digital system, but it's also a basis for science that can be applied into different industries.
Okay, wow, fascinating. You touched on smart nodes before, and we've read that you said on your website that smart nodes are the key infrastructure for digital transformation. I just wanted to know why you believe that.
Yep. So whenever we talk about sensors It started with sensor components, like ultrasonic probe, or it's a humidity sensor that you can tap into your system to the environment. But we see this has to be like renovated. You have to integrate the sensor with a microcontroller because microcontroller is cheaper. And you have the wireless connectivity, which is more pervasive. You have all the LoRaWAN connectivities around you. So if you can capsule them in the right form factor, a lot of more users can just use that, even they are not engineers. So we see this trend, and it's already smart sensors, smart nodes that you can deploy everywhere. And like I mentioned just now, with AI, it's becoming smarter. Meaning you don't need to send all the data back to the cloud. You don't need to like use the very precious battery power to send the unnecessary data, but you can process and compress the data on the device. So I can keep looking at all the images, and keep listening to the sound, and only send those information back with a short message. I look at this person without helmets.
Yeah.
So I don't need to send the picture back. Instead, I send, there is one person without helmets. So they can compress the data and save the energy. Then we can cover more pervasive situations with more precision and much lower like much lower carbon footprints as well.
Okay. Well, what challenges do sensors have at the moment?
Yeah, the most challenges we have is how do we maximize the node of power efficiency, longer distance of transmission. The precisions are across different sensors because it's an instrument. It needs to be calibrated and consistent. And it has to be low cost so you can deploy them everywhere. So it's mostly engineering challenges, but also how do we serve as many people as possible, even if it's small. So it's a very important partner with Digi-Key to outreach to enough engineers we have.
Okay, so that's one way of overcoming the challenges. Do you see other ways to overcome some of the challenges sensors are facing?
I think there's always new sensors invented. If you look at the exhibitors in this embedded world, or we look at the new sensors Digi-Key put up every day, it's a lot of new inventions in this domain, and we've seen a lot of new investments as well. Like for example, we used to have weather stations. It's like this room. You have all the like mechanic wind turbines, and you read them. But now everything is confined into a small cell. And instead of the mechanic parts, we use ultrasonic to tell the wind direction and speed. We use, instead of the little barrel to know the water, like a rain meters, we use optic manners to count the raindrops. So there's new ways we reinvent the sensors. So whenever we talk about sensor, it's not that the tiny sensors. It's maybe the much bigger infrastructure now can be minimized. So we see a lot of new possibility among that.
Okay.
And it's not only about digitalization. It's not only about AI, but it's a lot about materials. It's a lot about physics. A lot about new like silicon fabrications you can use for a sensor.
Well, what are some of the sensors that you've built?
Sorry?
What are some of the sensors that you, Seed Studio, have built?
We have built more than 1,000 type of sensors.
Oh, wow.
And especially sensor nodes. But now we are very much focused on outdoor sensors, like for environment monitoring, to know the weather, like microclimate. I think that's one of the most important sensor because for agriculture, if you need to know what would be the best plants of this region, you don't have the data from satellites. You have to install a weather sensor and also along with the soil sensors to tell from like one whole year to know it's the climates of the side of this hill, the side of this river. and to decide what would be the best plants to grow there.
Yeah.
So it's a beginning of the whole like operation. And we have more AI sensors. We have camera module, very low power consumption camera module, combined with very low power NPU, microcontrollers with neural network inside.
Okay.
So we can achieve always on sound, vision, processing, and transmit them back to LoRa. So it's very low power consumption, and and also the way to train these AI sensors has been much easier now. You don't need to do any programming. It's no code. We work closely with H-Impulse and other partners to do that. So now you can invent your sensors by training. And then we, of course, it has more like sensors for wearables, for movements, for water qualities, for like EC, like enteric conductivity inside the waters. And also we co-invent with Academy on carbon offset monitoring. So how do you know after the forest has been rebuilt, the carbon offset has been happening? You need to keep monitoring in a metric to know the changes, and also with air dynamics to do that. And wind sensor has been a very phenomenal demand. We install the wind sensors on top of wind generators. So when the wind generator starts, it needs to know where the wind is coming and how fast it is, so to make sure it's geared into the right direction. So another of these new innovations, and there is a smart odor, like smell. So by the multi-channel gas combined with AI, people use that to tell of the organic VOC, like the dangerous compound. You can smell it, and the machines can smell for you to avoid. And people use it for winery as well. So the formation of for the wine, you need to precisely control temperature, humidity, but also you can look at the color, look at the change of the smell to know, okay, it's ready to do the next process. Yeah.
Wow,
A
fascinating.
lot of them. I can keep on going for 1 hour.
well, lots of interesting applications,
Yeah.
but maybe we should move on to Grove modules. Can you tell us the features about these?
Yeah. So Groove is one of the first kinds of this open source module we built, because I was a lazy engineer. I don't like to look at data sheets and find all the pins and to do a breadboard to link them. It's because it's much easier to construct the circuits. So we construct for people. You can think it as a standardized API with a unified interface. You don't need to worry about the circuits. You just plug and play. We have all the library ready, and it's open source. You can, like whenever in scale, you can still reuse that in your products directly. So we keep doing that for 12 years at least. So we have accumulated a lot of these Groove sensors, and we are making more, like following the pace of the semiconductors.
Okay. Well, let's move on to IoT. The rising demand of IoT is driving more IT infrastructure to the edge. And what impact is this having on single board computers?
Yep. So as long as you have more demands to get data from the real world, very naturally, you don't want to have IDC whenever needed. So the edge computing instead of the cloud is on-premise to process the data. So you can do the inference, you do the data processing, storage on the fly. Then you just coordinate or transmit back the necessary information. So edge computing is becoming a more important role for IoT. Especially we see a lot of, because outdoor, we see a lot of situations there's no connectivity at all. You have to process the data on the situation. And also there is more camera. You don't want to send all the camera information back. So edge computing, especially edge AI, is doing that, doing the inferencing, and only capture those key moments.
Oh, okay. So, well, I was going to move on to say, what are the benefits of having edge optimized softwares and systems?
Yep. So a lot of software was built for pod situation, like on your computers, laptop, on the cloud. But for edge, the one of the most thing you want to avoid is to maintain it. So the software has to be running all the time, and you have to update, or maintain it from remote. So you have to do all the OTA. You have to the containers. You have to like coding them in a new way. So we have to as the IoT moves on, we have to do a lot of work from the node, from sensors to the microcontroller, to the edge computings, and to talk with them on the cloud side. And I see a lot of ecosystem partners have been done that well. But what we need to do is to optimize the sensors to make them as low power, as durable as possible. And deploying 100 of them is a challenge. So how, instead of programming each of them, can we use some app? Can we use just a very easy setup to deploy 100 or 1,000 pieces of that? So that's a new challenge on the software side.
Okay, well, I understand Seed Studio has built a fleet of edge devices. I was wondering if you could tell us more about that.
Yep. So, like we just randomly talked a lot of devices. Now, we have built several thousands of devices. What we look at them is, if we see them the whole thing, it's like a perception system. The ultimate meaning for our IoT system is how to get more data from afar. So we build it from modules, like the Groove system, then into devices, we call it SenseCap. So it's like LoRaWAN-based battery-powered sensors, but you can have all the readiness, like IP68, to deploy in the wild.
Okay.
Then, but after you have the sensors, it's far from enough. You have to send the data back. You need to have the network. You need to have the edge computing infrastructures to process that data. And like we were talking about, whenever there's no uplink connectivity, you need to process the data. You need mini servers. So along the track, we are building the full system. You can start buying from Digi-Key on seed product, even you have no IoT infrastructure at all. But with our subsystem, with our software and hardware combined, you can very easily to get the data for your operations. And then you can make more digitized in a very minimized cost. You don't need to replace your system, but we're providing a system for you to upgrade your legacy operations.
Wow, very fascinating talk, very insightful. Thank you very much, Eric. It was a pleasure speaking with you, and hope you enjoy the rest of the show.
Thank you so much. Very nice talking with you as well.
Thank you.